Welcome to the Professional Machine Learning Engineer Crash Exam course. Today we will focus on A2A protocol, an open-source, standardized protocol for secure communication between distinct AI agents. It aims to enable seamless collaboration and interoperability. The promise of A2A is that any compliant agent can communicate, delegate tasks, and share information, regardless of its underlying framework. The current state sees individual AI agents built on different frameworks operating in isolation, leading to the multi-agent silo problem. This lack of a common language hinders cohesive problem-solving. The A2A fix is a standardized framework that allows an AI agent to dynamically discover peers, read their capabilities, and securely negotiate UX and state. A2A and MCP are composable layers for production agentic systems, not competing standards. MCP focuses on vertical integration and stateless requests. A2A focuses on horizontal orchestration, is deeply stateful, and is used for multi-step planning and delegation between specialized agents. An A2A meta-agent distributes tasks to specialized sub-agents, which then use MCP for deterministic actions. The core architecture of an A2A request involves 3 steps. First, the user initiates the request. Second, the A2A client formulates tasks and orchestrates the workflow. Third, the A2A server provides an HTTP endpoint. The interoperability key is that all frameworks serialize internal state into the canonical data model, A2A proto, before transmission, neutralizing framework incompatibility. The agent card is the digital identity of an agent in JSON format. It includes the identity for routing, agent skills for structured capability declarations, capabilities for system-level features, and content negotiation for defining supported MIME types. A2A supports dynamic agent discovery through several methods. The well-known URI allows for broad, automated discovery. Curated registries enable strict governance by listing approved agents. Authenticated extended cards require clients to authenticate via OAuth to retrieve sensitive skills and internal system topology endpoints. The standard task workflow is structured around asynchronous tasks using JSON-RPC 2.0 over HTTPS. It involves 5 steps: capability discovery, task formulation, execution request, collaboration and state, and artifact generation. Interaction mechanisms, or transports, are matched to the task duration. Options include synchronous request/response for low latency, streaming updates for real-time incremental chunking, asynchronous polling for medium-duration tasks, and push notifications for significant state changes. A2A supports modality-agnostic UX and stateful continuity. It embraces unstructured modalities like text part, data part, and file part. UX negotiation allows client agents to declare UI capabilities, enabling remote agents to dynamically tailor responses. The context ID is a persistent identifier, preserving conversational threading. The first advanced topology is hierarchical structures. A central supervisor dynamically delegates tasks to specialized worker agents and synthesizes their disparate outputs into a unified result. This classic A2A production topology mirrors how human organizations manage complex projects. Advanced topology 2 is debate and consensus, where multiple distinct agents are networked together. They engage in structured discussions to evaluate options, critique reasoning, and converge on an informed decision. This eliminates single-model blind spots and is critical for high-stakes, low-tolerance decisions. Advanced topology 3 is the critic reviewer for self-correction. A producer agent generates a draft artifact, which a separate reviewer agent critically assesses for safety, compliance, and accuracy. This provides an essential architectural safeguard against hallucinations or non-compliant actions. The A2A implementation stack embraces agentic capabilities and allows unstructured modality collaboration without shared memory. Key components include agent card/agent skills, the ADK agent executor, and A2A Starlet application. The ecosystem natively supports major platforms like Google Cloud, LangChain, CrewAI, and MongoDB. Enterprise safeguards for security and A2A ops include mutual TLS for certificate-based mutual authentication. Strict header rules ensure secure credentials are passed via HTTP headers. Human-in-the-loop mechanisms trigger explicit human approval before irreversible actions. Finally, audit logs and tracing provide meticulous recording of agent flow and latency. Realizing the autonomous enterprise yields value synthesis for developers, enterprises, and end users. It breaks silos, eliminates integration glue code, and provides unified experiences. The quick reference glossary defines key terms like task, context ID, artifact, and agent space.